Okay, so now we are looking at the review on the theory and knowledge-based questions. So this is from the worksheet that I have, and I'm going to review all these 33 questions. So you guys, as I said, are doing fine on the math-based questions, but you're not doing good on the theory-based questions. So let's get this thing in. All right, so first of all, question number 1, which of the following is a physical property of aspirin? Okay, physical property. What does a physical property mean to you? What do you understand by physical property? Explain.
Yeah.
What is a physical property? Yes?
Something that you can see.
Something that you can see, you can feel, you can touch, you can smell, right? Something that you can measure, right? In physical sense, like for example, boiling point of a substance, melting point of a substance, right? Then freezing point, right? Specific heat, specific gravity, density of a substance, conductivity, malleability. Conductivity is like conductivity of heat, conductivity of electricity, right? And so those things. So we measure those things. Also, the conductivity is that heat, light, and like conducting, what was the other thing? Electricity, okay? Then there is malleability. Malleability is what? What is malleability? Yeah. What is malleability? Malleability is like when you beat things and they become thin wire, thin sheets. When you take like a what is it called, a hammer, and you beat on a metal, it flattens and it flattens. It doesn't crack, but it becomes flat. And when it becomes flat, what happens? It's like the thin, flimsy, like aluminum foils, right? Silver foils, those things. So thin sheets, malleability. Ductility is when you stretch it and it becomes wires. So you can make like wires of like a certain thickness, like copper wire, silver wire, or something even bigger, bigger wire. So it has that tensile strength, which means like it has got this amount of like it can withstand that stretching. So there's a strength in them. So those things, okay. So those things you should know. What is the physical property? All those things. Then look at this aspirin. Now, aspirin, we have already used at homes, right? Aspirin is, what is aspirin used for? Headache. So you know that it's a medicine. Like describe a pill of medicine. Describe it. Come on. Ibuprofen, or aspirin is a salt, which is like found in like medications for headaches. So what is that? Aspirin is an active compound. Chemistry, see, that's chemistry, organic chemistry. It's an active organic compound, which is marketed as ibuprofen or other things that contain aspirin. So when you look at the label, read the label of substances and see what is an active ingredient, and you will see if it says aspirin, then it's present in that. But there's another one, acetaminophen, which is different from aspirin, but that also causes, helps with like there are antipyretics and analgesics. Antipyretics prevent fever, right? Analgesics are for pain management. Okay. So anyway, so let's look at this. Aspirin can moderate some heart disorders when ingested. Is that a physical property? Does that sound a physical property to you? No. Next, aspirin does not decompose when tightly sealed in a bottle.
Yes.
So it is a physical property or a chemical property? Decomposition.
It's a
Chemical decomposition reaction. Remember those things? Okay, so that's not a. So we are looking at it's highly. Pay attention to the details. We're looking at physical. Next, aspirin yields carbon dioxide and water vapor. Physical or chemical? Chemical, very good. Aspirin can be pressed into tablets when mixed with cornstarch. Physical or chemical? Physical, very good. So you can make them like that's how they make tablets, they make capsules, they sell them as powders, or they sell them as like liquids or emulsions, or they can make them put the medicines in these creams and those things. Okay. Aspirin reacts with water, so reaction is obviously it's talking about the chemical. So there's only, so reading, right? It's reading, okay? So you get full points here, or you don't get full points, okay? So I don't want to depress you by saying that, but you need to now start practicing on these things. Okay, next, which chemical symbol represents a metalloid? Metalloid. Now, what is a metalloid? You should know what is a metalloid. What is a metalloid?
Between metals and,
Pardon me? So you see a metalloid are these guys, the ones that have some properties of the metals and some properties of non-metals. Not as strong as the metals in many ways, but not as weak as the non-metals also in many ways. Like, for example, silica, like carbon, silica, silica will conduct electricity up to like a certain level is needed to run these, computers and all those things. Okay, so as you guys know, you should know the metals, right? If you look at all these blue ones right here, these are the alkali metals. The second ones are the pink ones. The second, the second group. These are called the alkaline earth metals, right? The middle ones, the purple ones are transition metals. The purple ones, okay? Then comes the post-transition, the green ones right here. The green ones are the post-transitions. And then comes the reactive non-metals. All these blue ones right here are these reactive non-metals. They'll react with very, very reactive, highly electronegative, okay? And then comes these non-reactive elements, the non-reactive non-metals. And these are called the noble gases, right? And then the bottom, the blue ones, these are all actinides and lanthanides. These are the lanthanides. These guys are the actinides, lanthanum and actinium, okay? And then these guys are the relatively new ones that have been found. So know the periodic table, okay? All right, let's go back and see which ones were we talking about here. All right, next is, so which chemical is a metalloid? Which is this? Al stands for what? Aluminum. Is it a metal or a non-metal? Metal. So B is boron. Metal or non-metal? Gallium, gallium, zinc, and argon, right? So know the symbols of the elements and you should know where they are placed. So back to this periodic table, let's look at this one. Let's see, I have the last one. All right. Oh, this one is also like this. Can I flip it? Is there a way to flip it? Is there a way to flip it? Yeah, just flip it to the right side. Is there? Right. Oh, right here. Okay, we are here, right? Okay. So if you look at it, aluminum, but aluminum is not in the metalloids category. It is in that area, it is close, right? Gallium is not in the metalloid category. Indium, and then boron is in the metalloid category. That's step ladder, okay? And then what was the other one? I forgot now. Zinc is the transition element and argon is a non-metal. So pay attention to these things, okay? In scientific notation, the number, this guy is written as what? So remember, in scientific notation, this number is a very big number. So these zeros, where is the decimal in this number? Where is the decimal?
on the left here.
Make it bigger. Yeah, like here, better. Okay, so in the end, right here, you don't see the zero. You don't see the decimal. So what do you do then? It is an implied decimal. It's right there. What do you do? What do you do? You move it right to the left. 1, 2, 3, 4, 5, 6, 7, and 8. After the first digit, you stop here. So we moved how many places? 8. So what do? 10 raised to the power 8. 1.85 into 10 to the power 8. That's the answer. Okay. All right. Next is the next one. Let's put this here now on top. All right. Next is the how many neutrons does an atom of type? So what does type Ti stand for? What does Ti stand for?
Titanium.
Titanium, right? So it stands for titanium, and what does that mean? So now titanium is like it is 46 and 22. So you should know, what does 46 stand for? Mass number. And 22 stands for atomic number. 22 also means what? Protons, exactly. Protons, and it also means what? Electrons. So how do you find the neutrons then? Subtract 46 minus 22. So tell me, what is it?
24.
24. Very good. 24. Got it? Excellent. Okay. Which elements all belong in the same group? Which belongs in the same group? Now you have to see this very carefully. First of all, you should know, like when we talk about group, what does group mean? In a periodic table, what is the meaning of group? Valence electrons, they have the same valence electrons. But what is the meaning of group? Come on, guys, periodic table. Throughout the semester, group number. Like group 1A, 2A, right? 3A, 4A, 5A, 6A, 7A, 8A, right? These groups. So you just have to see that which group does these, you tell me. Look in the periodic table and see. Does carbon, nitrogen, oxygen belong to the same? No. So where do they belong? Where did that go now? Right here. Okay. So we are looking at carbon, nitrogen, oxygen, iron, copper, nickel. What about you guys? Have the periodic table with you? Iron, copper, nickel. And then comes the boron, silicon, and astatine. Where is it? Just 1 second. Okay, right here. Okay, so we are talking about boron, carbon, and nitrogen. So it's not the same group, but it's the same period, right? The next one was what?
Sodium, potassium.
What one is that?
There was sodium, potassium.
Sodium, potassium. Yeah, so lithium, sodium, potassium, rubidium, right? So the next one was the so we were talking about sodium, potassium, rubidium. Yeah, these belong to the same group. Aluminum, germanium, and antimony. Let's check this one also out. Aluminum, germanium, and antimony. Aluminum, germanium. Sorry, that's aluminum, gallium. But germanium and antimony, they are not even close, you know, SP. So you have to pay attention to their placement, understand groups and periods. Periods are these, horizontal. If we are talking about that element which is present in group 2A and 4th period, which one is that? Group 2A, 4th period. Calcium, very good. And if I say find an element that is present in group 3A, but in group 3A, 5th period. Group 3A, 5th period. Which one?
Yeah.
Pardon
Yeah.
me? Group 3A, 5th period, yes, Indian. Okay, IN, Indian, okay? So that thing, all right? So this way, so know the periods and the columns, okay? Next is the elements in the periodic table are arranged according to their what? Alphabetical order? Yes or no? Atomic number? Yes or no? Yes. So they are in the increasing order of the atomic number. difference between atomic number and atomic weight is different. Atomic weight is the weight of the isotopes. It's the average isotopic mass, okay? Next is the date of discovery, no. Number of neutrons, no, that's going to vary. So they are all arranged in the increasing order of atomic number. As you can see, here you have one, atomic number 1, and then comes the next one, sorry. And then comes the next one is placed obviously here, helium 2. Then comes lithium 3, beryllium 4, then boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, and neon 10. And then comes sodium 11, magnesium 12. You see that? So that's the increasing order of atomic numbers. All right. Next is the which where's the other elements in the then which column, there is a go, okay, which column of the periodic table contains only non-metals? Only non-metals. Is it 4A, 5A, 6A, 7A, or 1B? 4A, 5A, 6A, 7A, or 1B. So 1A is this, 2A is this. These are all metals. Now look at 4A. 4A is a mixture of non-metal, metalloid, and metal. 5A, same story. Non-metals, metalloids, and a metal. 6A, same thing. Non-metals, metalloids, and a 6A. And the last one is a metal. Okay, 7A is 7A. Now here, the thing is that astatine, I believe the question should, I think they forgot that this was maybe astatine, I don't know, because astatine is a non-metal, is a metalloid, sorry. So the rest of them, fluorine, chlorine, bromine, so the question actually should be worded more like, contains the maximum number of non-metals. That should be the wording, because astatine is, you see that AT, right here, AT, this guy is a metalloid. So only group 7A has a maximum number of non-metals. So that should be the wording, okay? Now, next is so here, which column of the periodic table contains maximum number of non-metals? So then it becomes 7A, okay? And not 1B. Now, where is this 1B? That's also another interesting thing. 1B, these guys in the middle are the B, right here. So 1B is all very strong metals, copper, silver, gold. These are very conspicuous metals actually, 1B. So that's not the answer, okay? Next is the, okay, next is which element with the electronic configuration is this guy? Okay, which element is the electronic configuration? So one way easily to do is what? You're going to add these numbers. 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 6, 18, and plus 1, 19. So which element has the mass number, like, oh sorry, the atomic number? Because remember, atomic number is equal to number of protons, and it's also is equal to number of electrons. So when you count the number of electrons, you're basically looking at which atom in the periodic table has that many electrons. So 19 in this case. Which one? Potassium, 19. So we are basically looking at the atomic number. Okay. All right. Now you remember that 1s2, 2s2, 2p6, 3s2, 3p6, and then comes 4s. After 4s comes 3d, and then comes 4p. So electronic configuration is important, you should know. All right. Next is, what is the electronic configuration of sulfur? Now here's also another thing. Another way you can also identify the elements is, remember here 4s1. What does 4s1 tell you? What does 4s1 tell you? 4s1 right here. Where did it go? 4s1 right here. What does the 4s1 tell you? What does 4 stand for? Period. Row. What does S stand for? Block. S block. What does 1 stand for? The first column in S block. Got it? The fourth period or the fourth row, S block, and the first column. And if you look at it, that is the placement of potassium. So potassium is where? Fourth period, right here, 1, 2, 3, 4. S block, these two are S blocks. And first column, got it? Now, that is the S block, group 1A and 2A are the S blocks. Then you come this side, these are the P blocks, because they're going to end in P. Got it? So the first number relates to the period or the row. The SPD, that belongs to the block. Now P can hold how many electrons? 6. So that is why you have 6 columns here. First column in P block, that means the ending is going to be P1. Second column in P block means the ending is going to be in P2. Third column in P block means the ending is going to be in P3. Fourth column in P block means the ending is going to be in P4. Fifth column in P block, fifth, sixth, seventh, like all that. So 1, 2, 3, 4, 5, and 6. Yeah. Fifth means P5, ending will be P5, and sixth will be ending will be P6. Once P gets filled up with 6 electrons, you move to the next energy level. Got it? Now same story with D. Now D can hold how many electrons? Yes, 10. So how many columns do you expect here? 10. But this is going to be D1. All these guys are going to end in D1. This one D2, this is D3, D4, D5, D6, D7, D8, D9, and D10. Got it, everyone? So that's, and then the last one, here are the F block. So F block, F can hold how many electrons? 14. Very good. So that is why you will see 14 columns. Clear? All right. Now let's look at back to this example. Where did we go here? Right here. Which element? Now, what is the electron configuration of sulfur? Now, where is sulfur present in the periodic table? Sulfur, S. Group, which one?
6A.
6A. So, and which side? What block is this? Which block? P. And what column? First column, second column, third column, fourth column. So it should end in what? P4. And what row? So this is the first row, second row, third row. So what should it end in? 3P. 3P4. Very good. So let's see. Besides that, let's see. So 3P4. So first thing, you cannot go wrong if you do that. So let's look at this. Is this correct? 2P2? No. Is this correct? P2, 3P2? No. Is this one 3P4?
Yes.
So hold on to this one because it's multiple choice. You know, there could have been something more. Is this one 3P6? Is this one 3D1? So this is the answer. But now double check. S is sulfur. How many electrons does sulfur have? 16. You see 16. So just go back and count. Just go back and count. So sulfur, 16 electrons. And here we have, in this case, so we have 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 6, plus 4, sorry, 16. Otherwise also, one energy level can hold only one has only one S orbital. Second energy level has 2 orbitals, S and P. The third energy level has 3 orbitals, but you can only fill in as many electrons, so if there are only 16, so you fill up the S first, then fill up the 2S2, then fill up 2P6, then go to 3S2, and then any remaining goes here. All right. Now, if I ask you to draw the orbital diagrams of P4, S2 and P4, what will you do? How are you going to make that P? How many orbitals does P have? How many orbitals P have? 6 is the electrons. 3. Each orbital can hold how many electrons? 2 electrons. And these electrons are in what kind of spin? Opposite. One clockwise, the other anti-clockwise. So when you fill up the electrons, how are you going to fill them? How are you going to place the 4 electrons? What rule will you follow? No. What rule? Fully filled and partially filled orbitals are more stable, right? So first you're going to partially fill. For P4 means there are 3 orbitals, right? Draw the 3 orbitals. See, if I'm the one who has to draw all the time, then you guys don't learn anything. You guys draw 3 orbitals, draw through three circles. 3 circles. Everybody done that? Done it? Everyone? Some people just sitting like this. Okay. Okay, so P4, so 3 orbitals, 1 electron singly occupied, first one, second electron singly occupied. Singly occupied means just 1 electron in the second orbital, 1 electron in the third orbital. How many left now? P has, you need to place 4 electrons in P, right? You already placed 3. So what happened? How many left now?
1.
Where is that going to go?
To the first.
To the first one. Very good. Got it? So that's what, we will see. Do you know orbital diagramming? Can you do that? And if you don't do that, it's -4 right there, -5 actually. Final exam, -5. All right. Next is the element which has 4 valence electrons. Now, what is the rule regarding the 4 valence electrons? Valence electron. What's the rule? What's the rule regarding valence electrons? Group number. Excellent. So 4 valence electrons are in which group number? Which group number? 4A. So is oxygen in 4A? Look at your periodic table. Beryllium, titanium, lead. Yes. So 4 valence electrons. Lead. Sulfur? No. So which group is sulfur in? 6. Titanium? Look in the periodic table, tell me, which group?
4B.
Which one?
4B.
4B. Yeah, B is different. Okay, that's a good point. Now, all the B's, the middle ones, the B, right? They all have 2 valence electrons. Remember that they are D2 and then 4S2. So all of them will have like D, whatever, but 4S2, 5S2, 6S2, those are still the last shells. Those are the valence electrons. So that's why. Okay, so beryllium, what's valency? Valence electrons of beryllium. 2, because 2A. Oxygen? Oxygen? 6A. Very good. So 6A. Excellent. Okay, very good, guys. So next is, which of the following have the largest ionization energy? So largest ionization energy. What is ionization energy? What is ionization energy?
Electronegativity.
See that again?
Electronegativity.
Relates to, okay, very good. So ionization energy relates to electronegativity. Okay. Shh. Okay, guys. Ionization energy relates to electronegativity, right? What else does ionization energy, like it refers to?
Quantity of energy.
Pardon me?
Quantity of energy.
Lovely.
Quantity of energy.
Quantity of energy? No. What does ionization lead to? What is ionization? Pardon me? Okay, ionization means what? Like literally, like from English perspective. Come on, guys. What are the 2 types of ions you know? Only 2 types of ions in chemistry. Entire like cosmos. That's a guarantee. Even in multiverses, only 2. Which one? Oh, positive and negative. Yes or no? Yes or no?
Yes.
You guys are exhausted, I think. I wish there was some coffee or something, some food or something for study sessions. Anyway, just bear with me. Okay, I know you guys know it. I know you know it. It's just, I think you guys are just tired. Okay, ionization. Ionization means, okay, in this case, ionization energy relates to removal of electrons. Removing electron creates what kind of ion? Positive. Very good. So when you remove electrons, a positively charged species comes. What is the name? What is the name? Cut. Starts with cut. Cation. The name of a positively charged ion is called cation. Cation. Okay. So removal of electrons is. So which element? It's going to be very difficult to remove the electrons. Neon, bromine, phosphorus, aluminum, calcium. Very difficult to remove electrons. Which one? Neon. Very good. But why? Why? Why?
Has a full valence shell.
Has a full valence shell. 8 electron rule, noble gases. Very difficult to remove, once they're fully occupied orbitals. Electrons are paired, all of them. So that's why very difficult to remove electrons. So technically you can, in chemistry, change reaction conditions and you can get, what you want. But the problem is you have to have very rigorous reaction conditions, very high amount of energy, long time, right? So that's why. So very difficult to remove those electrons. You can remove them, but it will take a lot of time. So ionization energy. Besides that, the quickest, so this was your, I was just making you think, but I also have this on your handout right here. Okay, back. All right, right here. So increasing ionization energy means as you move in the periodic table from left to right, you will see an increase in the ionization. Like lot of energy needs to be given to all the elements that are this side. So the more electronegative an atom is, the higher the ionization energy is going to be. The more electron affinity is. They love electrons. Why will they give away electrons? You see that? So if they don't want to give electrons, then you really have to give a lot of energy to rip the atom of the electrons. Okay. All right. Let's look at the next question. So in that case, it was an answer. All right. Next is. All right. So now, all right. Next, what is most likely charge on an ion of an element with a valence electron configuration? Now, this is a generalized question. But so what is the most likely charge on an ion of an element with a valence electron configuration of Ns2, N2, So it's not specific to any element, but let's say any element that has got an Ns2 and Np4 electron configuration, what charge is going to form? -2. Why do you say that?
Because 6 valence electrons, so it takes 2, they're completed.
Very good. P can hold a maximum of 6 electrons, right? Right now you're only showing 4. So you just need, it's better to only give, it needs only 2 more so that all the electrons get paired, right, in P, and then that's a good thing. It's less energy and octet rule. Fully filled orbitals, more stable. Octet rule, that is also met. Then it becomes with 6. Then it becomes 6. 6 plus 2, 8. So it's easily. But it is difficult to remove the electrons. So any one of these electrons from Ns2 and Np4 means like they are so close to meeting their octet. That's what it means. So that's why taking electrons is more like easy and feasible. So this becomes -2. Because 2 electrons are just needed to get the octet, -2. The rest of them, now here I've seen the student get confused between 2 and +2. You see, just that, and they feel like bad, like it's just a plus sign and minus sign. No, minus sign has a big value in chemistry. This minus sign and this plus sign, it's all movement of electrons. Okay, there is one field in chemistry called electrochemistry, where it's all about electrons. You see that, the whole discipline, in fact, okay, when you study Chem 1A, you're going to be studying these redox reactions, oxidation reduction reactions, and you will be balancing electrons. There's a method called half cell method balancing. It's not the kind of balancing, you see different methods of balancing. You only learned a very simple basic one, but there's a method of half cell balancing in which we only balance electrons. So that's why, so this plus and minus has a huge value. Anyways, okay, which of the following elements is most likely to form an ion with a -2 charge? Which one will form a -2 charge? Now, -2 charge means whatever element you have, it only needs 2 more electrons. -2 means it will gain electrons. Yes or no?
Yes.
Yes. So it will gain electrons. That means it's just going to get the octet met. So obviously here, look at magnesium. What does magnesium have?
2 valence electrons.
2 valence electrons, right? So it doesn't need to take 2 more. It's not needed. Silicon, look at silicon. Where is silicon present?
4A.
4A. So how many valence electrons there are? 4. Okay, but hold on to this one. Silicon -4. It has got 4A, and -2 would only make it 6, right? So that doesn't make sense. What about this guy, sulfur?
6A.
It has 6 valence electrons, and you need 2 more to get the octet. So that's why this is a better. What about potassium? 1A. How many valence electrons?
1.
So always the easy thing is group number valence electrons. Simple. 1A. So -2 doesn't make sense. What about titanium? 4. It is in the B block. Yeah. So see, another thing is metals. All the metals. What kind of charges?
2 positive.
Positive. And non-metals? Negative. Simple. Right? So that also you can look at it. Okay. Next, which pair of elements is more likely to form an ionic compound? One second. I wonder if I'm recording. Am I? All this is going to be a futile.
Yes.
Is it?
Yeah.
Oh, yeah, this thing is blinking. Okay, yeah, it's good to check because other students can benefit from it now. All right, let's do this thing now. Yeah, so now we are looking at which element, which of the following have the largest ionization energy, which is most likely with the valence.
48.
Which one are we doing? Oh, this one, 14. Which pair of elements is more likely to form an ionic compound if allowed to react together? Now, ionic compounds, now this is testing your knowledge. Number 1, do you recognize a metal? Do you recognize a non-metal? Do you know that ionic compounds are formed when a metal and a non-metal react? So now I'll go back and look at it here. Aluminum and silicon. Will they react? Aluminum and silicon. What is silicon? What is a silicon? Metalloid. Yeah, so forget it. What about iron and calcium? This will it form an ionic compound? No, because both of them are metals. What about carbon and fluorine? No, because carbon is non-metal, fluorine non-metal. So it's always ionic is between metal and non-metal. What about here? Potassium and bromine. Yes, metal and non. So that's what we are testing here. What about hydrogen and nitrogen? No. So these would be covalent. Non-metals are covalent. Okay. What 4th period element is represented by the dot structure? So something X is just that element X with 2 dots. Which one? Potassium, which group? Remember, dots represent what? Valence electrons. Very good. So potassium is in which group? 1A. How many dots? Calcium? Dots? Okay, hold on to this one. Vanadium, actually. Vanadium. Vanadium. Okay, where is vanadium present? Where is it? Where is it? What kind of element is it? Transition. And what did I tell you just now? The valency of valence? 2. And all +2. And then variable also. The transition elements, many of them are variable also, like copper will have +1 and +2. Iron will have +2 and +3, right? What is the other? Like, for example, lead will have +2 and +4. Tin will have +2 and +4. And like, for example, manganese will have +2, +5, and +7. And bismuth, I think, has +2 and +5, right? And then there are many others, like chromium has +2 and +3. Okay, so this I remember just off my memory, but I have a group in your handouts, so you have to kind of, the more you see chemistry, the more practice you do, the better you get. Anyway, so these are your elements which are present in these transition elements, which all will have one thing common, +2. And where is that +2 coming from? From the S. Their last electrons are in 4s. 5. The filling of the electron is in an order, but the valence electrons are always the last shell electrons. The last shell is the highest shell number. That's the valence. So vanadium belongs to the transition. So it will be 2 dots. What about this one? AS. Astatine.
6A.
6A. Which fourth period element is represented by the dot structure with +2? 6A with +2 charge. Oh, wait, 1 second. Calcium is in group 2A, right? So it will be +2 charge. So 2 dots here. Yeah, astatine is 6A. So how many dots here? 6. And chromium? 8. 8 dots. 8. So keep that. Okay, next. Moles. Huh? B, calcium, yeah. Okay. 1 mole of particles of any substance contain how many particles? Now, this is your common knowledge. Yes. I see. So I see students. Sometimes, okay, students get confused. I think it's all math and all. Like, it's not math, it's like exam anxiety, I think, or whatever. Minus 23 and 23. They get confused here. So what is the right answer?
D.
D. Why? Why? Avogadro's number, 10 to the power 23 and not -23. Don't make a difference. Don't make this is a very small number. Very, very small number, like just practically impossible. You can say this is a very small number, but positive is a big number, right? But when we are looking at atoms, that is why Avogadro's number. Okay, so the rest of it is this. Okay, next, shape of a molecule in which the central atom forms 3 single bond and has 1 lone pair. Now, shape of the element which has a central atom. Central atom is A, 3 single bonds, right? And 1 lone pair. So 3 single bonds mean 3 bonded atoms. So X, 3, and 1 lone pair, E1. So go back. So I'm not expecting you to remember this one very specifically, but at least you should know. 1 central atom means A. Where is that page? 3 single bonds means 3 bonded atoms, single bonded, and where did it go? Right here. Okay. So we are looking at A. A is the central atom. X is the bonded atoms, the 3 bonded atoms by the single bond, and E stands for the lone pair. So we are looking at AX3E1. Where is that? AX3E1. AX3 here. AX3E1. AX3 bonded atoms, 1 lone pair. Now tetrahedral and trigonal pyramidal. So you have to pay attention to this. Electron group geometry is internal, inside, and the molecular geometry is outside. Molecular geometry is from outside. So if the question is saying that trigonal pyramidal AX3. So try from outside, it looks like a pyramid, but internally it's like a tetrahedral, like a three-legged chair, a chair with three legs, okay? All right, next. All right, next is the shapes of the molecules in which so this one we did. Pardon me? One second, it's linear, planar, pyramidal. So yeah, so you see, pyramidal or tetrahedral. Tetrahedral is the electron group geometry. But when we talk about the shape of the molecule, that means molecular shape, and molecular shape relates to pyramid. So it's D. All right? Yeah. All right, next, consider the molecule. What is the name of this, guys? Come on. What is this? SiCl4. Si is what? Cl is? And 4 relates to? Tetra. So this becomes what? Very good. Silicon tetrachloride. Okay. Now the electronegative values of this is given to you here, but you should know where they are in your handout. Also, you may need, see, okay. All right. Okay. Now open your ears, everybody, whether somebody's online and you guys in the classroom, everybody listen very carefully. Chemistry, all the time, we are not going to say show working, show working, show working. No, there is an implied working. In order to reach to one answer, you need to know all this back theoretical information, and sometimes the theoretical information wants you to like, do some little minor calculations or refer to a table or those things. So we are not going to say like show working, but we would expect you to show that working, do the working. You get that, everyone? Everyone got it?
Yes.
So that's something, you should, when we say, oh, this tell whether this particular bond is polar or non-polar, right? And so fine, with time we kind of get used to it, but because you guys are still learning, so I would expect that you should at least show if it is polar. How did you get it? It's polar. How? You look at the electronegativity values, subtract them. If the electronegativity value comes from 0 to 0.4, then it's non-polar. But it's from 4 to 1.8, then it's polar. So you show how did you reach that conclusion. You get that? So this is how, you will do that. Okay. Anyways, next is, so in this case, now you are given the silicon and chlorine values. Based on these values and on the consideration of molecular geometry, the silicon-chlorine bond is what? Silicon and chlorine bond. How would you find that silicon-chlorine bond? Polar or non-polar? How? I just now give you a clue. Subtract. Very good. So 3.0 minus 1.8. What do you get?
1.2.
Say that again.
1.2.
1.2. And when you look in this table, 1.2 is falling. The difference in electronegativity is falling in which category? Polar covalent. Very good. So polar covalent means what? That so now silicon tetrachloride. How many bonds can silicon make? Silicon is in which group? How many silicon will make? It has got 4 bonds, like it's got 4 electrons. It needs 4 more. So it will make how many bonds? 4 bonds. That's why it's connecting to chlorine. Okay. Now 4 chlorines with silicon. So it's like you make a shape, silicon. So it's a tetrahedral shape. Each bond is a polar bond. So that's one piece in this question. But overall molecule, what happens? Non-polar, because it cancels out. It's an equal pull. It's the same pull on all the 4 sides. Got it? Same pull on all the 4 sides, cancels out. So overall molecule becomes non-polar. So the answer is C. So, you have to be careful when you are doing this. So look at this, like here, they have just to confuse you, non-polar and polar, and like, so read and, carefully do it, okay? All right, next is, which of the following equations is not balanced? So what will you do here? For not balancing, what will you do? What will you do? Yeah, so just see, it's just, they just want to see, okay, there are two sodiums here, two sodiums here. How many hydrogens this side? Four. How many hydrogens this side? Four. So this is balanced. So we are looking at not balanced. How many hydrogens here? How many here? Oxygens? How many hydrogens here? How many oxygens? Balanced. What about here? How many aluminums? On this side? How many hydrogens? And this side? How many chlorines? So on this side? 6. Very good. Balanced. Look at this one. How many carbons? How many here? How many hydrogens? And how many hydrogens? Look at oxygen. How many oxygens? 10. Do we have 10 here? 3 2s are 6 plus 4, 10. Balance. What about this one? 1 sulfur. How many oxygens? 4. And here? So not balanced. So this is the answer. D. Okay, not balanced. So next is, which one of the following compounds will be insoluble in water? Insoluble. So what are you going to do? Ideally, you should memorize. Ideally. That's a very ideal situation. But I gave you a clue here. What is that clue? Now, I've gone through this throughout semester. Now you guys tell me. You guys tell me now, look at the solubility table and tell me, what about this one? AgNO3. AgNO3, soluble. So when it is soluble, what is the meaning of that? What is the meaning of solubility? The AgNO3 is nitrates. All nitrates will be soluble in water. This means they are going to ionize in water. They will break up into ions. What kind of ions? Ionize silver nitrate? Come on. It's not that hard. Come on, guys. AgNO3. What's the charge on NO3? Yes? Nitrate. -1. Very good. And charge on silver? Yeah? +1. Yeah. So +1 and -1 cancel out. So silver nitrate will ionize as silver ion and nitrate ion. Very good. Okay, what about the next one? CaCl2. Soluble, insoluble. Remember, these are those bad guys. Gastrobar. And where is it found? In the mall. Right? Which ones? What makes gastrobar?
Calcium, strontium, barium.
Excellent. Calcium, strontium, barium. These are the troublemakers. They say they become, when everybody is soluble, then they'll be insoluble, or they'll be partially soluble. And when everyone is insoluble, then they will become soluble. Moody. So calcium, group 2A. Magnesium also a little bit, but these are the notorious ones. Barium, strontium, calcium. These guys. And what makes the mol? What's in the mol? Mol. M stands for mercury. A stands for silver. And L stands for lead. So these guys are another ones which kind of like in this, these are the goons of the periodic table. So calcium chloride. So what's the thing? Chloride. All chlorides are soluble except calcium chloride. So I don't know if it's partially soluble or insoluble. So that's, I think it's partially soluble, right? Right, so these are this would be insoluble, so hold on to this. Okay, now this is another thing, guys. So question, when we say partially soluble, what does partially soluble mean? That partially is insoluble. Yeah, sparingly soluble, but some part is insoluble, right? So it still comes in that insoluble category. Okay. Okay, what about ammonium chloride? Soluble, insoluble? Why is it soluble? Ammonium, just the sweetest thing in the periodic table, like, or not in the chemistry, like just ammonia, like ammonium, like it's just ammonium chloride. Soluble, anything ammonia, ammonium attaches to anything, makes it soluble. So, okay, what about calcium carbonate? Heavily insoluble, right? Remember, where does the calcium carbonate belong to? Which category? Carbonates. Now, carbonates are insoluble, right? And what about the other one? That's the lead acetate. And all acetates are also soluble. It looks like a very big, weird compound, but it is soluble. Okay. So calcium carbonate. So now, if there is a conflict between calcium carbonate and calcium chloride, so calcium chloride is partially soluble, partially insoluble. But if the question is asking like all insoluble, then calcium carbonate 100% guaranteed is never going to dissolve. Okay, in water. And something that does not dissolve in water, that means, what is the suffix for that? Like, no, the little, that thing that you put, like, what is it called? That little subscript? Kind of. What is that? S. S stands for solid, and AQ stands for aqueous. Aqueous means ionize, and S means will not ionize. S means solid, will not ionize, but AQ means ionize. Okay. All right, now let's look at the other one, volume and pressure in gases. What is that?
What was 20?
Pardon me?
What was 20?
Pardon?
What was 20?
So calcium carbonate, D. Okay. All right, 21. Volume and pressure. Volume and pressure, guys, come on. Remember that? Boyle's law, Charles' law. So volume and pressure. How are they proportional? Directly, inversely? Inversely, yes. Inversely means, what is the meaning of inversely? One goes up, the other goes down. Very good. All right, next. So we have a few more left. In the reaction shown, dash is the oxidizing agent, because now oxidation reduction, the reactions. All right, now look at this. Right here, rules for assigning the oxidation numbers. All the, what are oxidation numbers, by the way? What are oxidation numbers? They're just like the valence electrons, just like the charges. All right, positive, negative, same thing. The only difference is it's a little bit more. We are looking at the movement of electrons. Has the electron left the atom at one point of, like, it's a very fine thing. When it's, you look from outside, when you're doing these reactions, you just add two things. And from outside you see this, but now we are going inside the atoms and molecules, and we are seeing what is happening, which electron is giving electron. When were the electrons given away? Who started the reaction? What is the exact time when the reaction started? So that's all the bookkeeping of electrons. That's the oxidation numbers. So pretty much it's the same thing as the charges, but and a little bit more. So now let's look at a little bit more. What is that? So oxidation number is a number, of course. Element in free state. Free state means what? Uncombined, right? When it's not combined with anything. What is that? It is 0. So oxidation number of elements in free state is 0. What about the, like for example, copper, iron, silver, like lead, anything that is just not combined with any other, like not even oxygen. So that's free status. The oxidation number is 0. Means the electrons have not left copper. Copper can give away 2 electrons. Copper can give away 1 electron. But the electrons have not left yet. That's what it means. Okay. Next is the oxidation number of diatomic molecules. Diatomic. What is the meaning of diatomic? 2 atoms. So you see hydrogen, H2, O2, Cl2, N2. What is that? 0. Means that the atoms are now tied up with each other. Electrons are not available to move around or for any other atoms and so forth, so the electrons are taken away. So here, that's why it is 0. Hydrogen, always +1 except for metal hydrides. Metal hydrides, very like they catch fire. So metal and hydride. Hydride is H -1. Okay, when like for example, sodium combines with hydrogen, then it's -1 on the hydrogen. Similarly for oxygen, all the time it's -2 because oxygen has 6 valence electrons. It needs 2 more. So that's why it's always -2, except when in peroxides. In peroxide, it's -2. Okay, the oxidation number of group 1A +1, group 2A +2, 3A +3, 4A +4, 5A, like that. It's the same thing as the group numbers, except 5A would be -3, 6A would be -2, 7A would be -1, and 8A is 0. But there are exceptions also. So that there are some ways you have to calculate the oxidation numbers through, like, the algebraic processes, okay? Oxidation number of all groups, like 7A, like I said, it's -1, but there are exceptions. Now, for example, for group 7A, okay, group 7A, chlorine in HCl is -1, but when chlorine there's oxygen in a molecule, right? Oxygen, chlorine combining with oxygen, more electronegative, then it is +1. But I don't want you to, because obviously you can't remember this. So there's a method of finding, we discussed that, for those, you will have to look into this, how to calculate it. Of the ions, the total charge on all the atoms in the ion is -2, and the oxidation number for neutral, the sum total of the oxidation numbers of all the elements in a neutral molecule is 0. Like carbon dioxide overall is 0, but carbonate -2 charge, the sum total of carbon and oxygen oxidation numbers is -2 in a carbonate. Okay, so that's the deal with the oxidation numbers. Now we are going to look here. In this case, neon, free state, see, solid. So what is the oxidation number?
0.
0. Very good. So here, copper, free state, what is the oxidation number?
0.
0. Now let's look at it. Copper chloride. What is the oxidation number of copper here? I mean, oxidation number is equal to the charge. What is that? What is the charge on copper? What is that? +2. How do you know? How do you know? Because it's combining with 2 chlorines. Remember that crisscross. It's +2 here, that goes down, -1 here, goes here. So copper has +2 charge, that's why it needs 2 chlorines with -1 charge each. Okay, so +2 on copper. Next, nickel. What about nickel? What's the charge on nickel here? +2, same thing. And chlorine? -1. So chlorine is the same, -1, -1. Now let's look at it. Nickel has gone from 0 to +2 state. So 0 to +2 state. So here's the thing, when there is an increase in the oxidation number from like, negative to 0 to a positive side, where is it? From a 0 to a positive side, that is oxidation. And when there is a decrease from a neutral to a negative side, it is reduction. Okay, so reduction is decrease in the oxidation, like negative charge increases, or lesser positive charges. Okay, like for example, this one was +1 charge, and this has become +2 charge, it's oxidation. But if it is -2 charge, and it has become -1 charge, that is reduction. So here we see this now. So here 0 to +2. So which one got oxidized? Nickel has gone from 0 to +2, right? So what is that? Oxidation. Copper has come from +2 to 0. What happened to copper? Reduction. So here you see that nickel from 0 to +1. Nickel is oxidized, so A is not answer. nickel gets reduced from 0 to +2, no. Copper chloride, copper has gone from +2 to 0, yeah, so copper, so +2 to 0. What happened to copper? Copper got reduced. Copper itself got reduced, but copper, when it gets reduced, once again, CuCl2 gets reduced. Yeah, so its answer is D. Copper went from +2 to 0. So this gets reduced. And then nickel chloride, nickel has gone from 0 to +2. No, nickel gets oxidized. Okay, so keep this in mind, the entity that gets reduced acts as the oxidizing agent. Clear? And the entity that gets oxidized, like nickel, acts as a reducing agent. All right?
That's D.
So the answer is D. Copper chloride gets reduced. But it's acting as an oxidizing agent. Okay, next, in a molecule with covalent bonding. So what do you know about covalent bonding? What do you know about covalent bonding, guys? What is covalent bonding? Sharing of electrons, very good. So sharing of the electrons, not giving away. Ionic is giving away. Ionic is metal, non-metal. Covalent is sharing, and that is between what? Metals or non-metals? Non-metals. Non-metals, covalent bonding. Clear? Here, I'm liking like how some people are taking like all these notes because the thinking process, right? So when you get a question, that thought should come in your mind. Okay, covalent, what do I know about it? And then you read, okay, oppositely charged ions are held together by strong electrical attraction. Oppositely charged ions. Is that true? Why? That relates to opposite charges, ions relates to ionic. Very good. So that doesn't apply. Atoms of metals form bonds to the atoms of non-metals. No, this is ionic. Okay. Atoms of different metals form bonds. No. Next is atoms are held together by sharing of electrons. Yes. Atoms of noble gases are held together by the attractions between the oppositely charged ions. Noble gases don't care, you know. So sharing, part D. Okay. All right. Which change to this reaction would cause the equilibrium to shift to the right? Remember, equilibrium. What does this relate to? What are we talking about here? What principle is that? Name. Le Chatelier's principle. Charles law and gas laws, right? Yeah, okay, good. Anyways, but good try. So Le Chatelier's principle, yeah, good. Okay, so what does Le Chatelier's principle tell you? What do you know about that? Yeah. Le Chatelier's principle, what do you know about Le Chatelier's principle? That relates to equilibrium, yes or no? Yes, okay, at least that's correct. Okay, so when the equilibrium are useless reactions, you can get the products, you lost your reactants. The moment you get the products, they become the reactants again. Reactants are pushed to make the products, but then it just keeps going back and forth, back and forth. You cannot isolate neither the reactants nor the product. But what to do? What can you do? What happens in a Le Chatelier's principle? What does he say? Like, what can you do? Apply what? Stress on the equilibrium. And where do you see the response? In the opposite direction. Good. Now here, look at this nitrogen. So what kind of stress can you apply? What kind? What can you do?
Taking away reactants.
Either you remove the reactants or you can add more reactants. One piece. Same thing applies to the product side also. You can add more products or you can remove the product. I mean, you will have to bring that product now from outside, from somewhere. Okay, so concentration, change in concentration. Besides that, what else can you do? If it's an exothermic reaction or endothermic reaction,
Raise or
lower the heat or increase the heat. Because heat, what is the deal with the heat in that case? In exothermic reaction, what is the heat a part of? Heat is a part of products. Exothermic reaction, the heat is a part of product. And in an endothermic reaction, the heat is a part of reactant. So same story now, just like you add a reactant, the same thing you can add heat, and you will see the reaction will be pushed in the opposite side. What about catalyst? Can you add a catalyst and disrupt the equilibrium? No effect. No effect. Catalysts have no effect. Okay. Now, the last one. Because these equilibriums, generally, they are set with the gases. Now comes the volume. When you increase the volume, what direction is the equilibrium going to move? Whichever side there are more. So it doesn't follow like any other. So you just count the number of moles. How will you count the number of moles? How? Coefficients. Very good. So look at the numbers in front. Just count them. Whichever side is more. If you increase the volume, you say more that side. Or if you decrease the volume, less moles. Okay, towards the left. Okay, now let's look at this. Which change in this reaction was called the equilibrium to shift to the right? Now to the right is towards the product side. All right. Now, if you add a catalyst, is something going to happen? No. Next, adding ammonia. If you add large amount of ammonia, is the equilibrium going to shift to the right? No. You're adding large amount of ammonia here, so it's going to shift where? Backward. Removing hydrogen. You remove hydrogen. Where is the equilibrium going to move? Huh? You remove hydrogen. Backward. Now ammonia will push, to make more hydrogen. Next, heating the system. Large amount of heat is added here. Remember, heat is a product. Large amount of heat is added, pushed back. So it's moved. Lowering of the temperature. Lowering of temperature means what? Removing heat. Remove heat. Now you remove heat. Forward. So now that is the shift to the right. So lowering the temperature is removing the heat. It pushes the reaction to the right. Okay, got it? All right, consider the following 4 liquids. Now, again, I've given you a clue here. I'm not going to give you these clues on the exam. The rule is like dissolves like. Polar, the solute gets dissolved in polar solvent. Non-polar in non-polar. Okay, so now here they have given you some things about water. That water is highly polar and hydrogen bonding occurs. Clear? Hexanol. Now you don't know hexanol, I understand. But what they are saying, it's a metal. I'm sorry, not a metal. It's an organic compound. So don't worry about the structure and everything for your course. But it is slightly polar and it can show some hydrogen bonding. Okay. Chloroform. Chloroform is again slightly polar but no hydrogen bonding. Next is octane. Octane is again, these are all organic compounds, non-polar. All carbon hydrogen bonds are non-polar. That's octane and no hydrogen bonding. So we see hydrogen bonding in 2, water and hexanol. Now, which pair of liquid is immiscible? Immiscible means insoluble into each other. Now, first of all, let's see. Is water and hexanol going to mix? Water and hexanol, are they going to mix?
No. Hexanol.
Water and hexanol. Okay, like dissolves like, listen carefully. Like dissolves like. Polar will dissolve in polar, non-polar will dissolve in non-polar. So here you have one is polar and the other is also slightly polar, but nonetheless it is polar. This guy has hydrogen bonding, this guy also has some hydrogen bonding. So more or less similar intermolecular forces. So these will mix. Water and hexanol will mix. You get that? Everyone? Okay. Now let's look at the next thing. So we know these are 2 polar. Next is, this is slightly polar, but there's no hydrogen bonding in chloroform. So which is it going to mix with? More, water or hexanol? chloroform is going to mix more with water or hexanol? Hexanol, because that's slightly polar, the other one is also slightly polar. There's some hydrogen in bonding in one, but no, but that's like secondary, but little bit like both of them are polar. Hexanol and chloroform will win, but is chloroform going to mix in water? No, because one is highly polar and the other is less polar. The one has hydrogen bonding, huge, the other one does not have hydrogen bonding. So slight solubility may be possible, but pretty much they won't mix. What about octane? Is it going to mix in any of the three above? Octane. Because see, the top ones are polar, slightly polar, right? But octane is non-polar. So non-polar will not mix, not at all with water. Hexanol, not at all. Chloroform, maybe a little bit, I don't know. But because at least there's no hydrogen bonding, but maybe a little bit, partial solubility type of thing, okay? Now let's look at it. The ones which are totally insoluble. Which are the insoluble ones? Chloroform and octane. Water and hexanol, 100% for sure. Oh, no, insoluble, water and hexanol will mix. Hexanol and chloroform, water and octane, never, water and octane. Because one is highly polar and the other is non-polar. So answer is A. Okay. All right, next is which substance is not an electrolyte? Now, what do you know about electrolytes? Yeah, what do you know about electrolytes? Electrolyte. Remember, strong electrolyte, weak electrolyte. Okay, electrolytes means the one they dissociate in water. And they conduct electricity and the bulb lights up. Okay, so that's a demo part, which I'll do it just now. Okay, which substance is not an electrolyte? Means something that will not dissolve in water or something that is not going to dissociate in water. So sodium chloride will dissolve in water. It's soluble in water. HCl will dissolve in water like it's soluble in water, so it will conduct electricity. Ammonium nitrate will dissolve in water and it will conduct electricity. KOH will dissolve in water, group 1A, K and OH will dissolve in water and will conduct electricity. But this guy, always carbon, hydrogen, carbon, hydrogen, carbon, hydrogen, they don't conduct electricity. Make a note of it. So carbon hydrogens are weak or non-electrolytes, basically. Okay. All right, almost done. pH of the acidic solution. What is that? That's easy. pH of the acidic solution, less than 7. Next, ammonia reacts with the acids because ammonia. Okay, ammonia reacts with acids because it contains lone pair of electrons. Ammonia acts as a base, and base is something that can give away electrons. Okay, so ammonia has 2 electrons. Remember that structure of ammonia, 2 electrons sitting on the top of the pyramid, 3 hydrogens at the base. So those 2 electrons participate in like acid-base reaction. So they make those 2 electrons, lone pairs on ammonia, make it basic. So this is from your chapter 11. Okay, so it contains lone pairs. So answer is E. Okay, 29. Which of the following molecules can form hydrogen bond? Now, what is hydrogen bonding? Quickly, what is hydrogen bonding? Which ones? Only 3 are there. Nitrogen, oxygen, fluorine. Excellent. So anytime there is oxygen, nitrogen and fluorine present with hydrogen, like OH, like NH, like HF, only then hydrogen bonding is going to occur. It's not like oxygen is present in a molecule in between the 2 carbon atoms, then the hydrogen bonding will occur. No, a good strong hydrogen bonding will only occur when oxygen and hydrogen OH bond is there, NH bond is there, or HF bond is there. Get it, everyone? Next, hydrogen of the neighboring molecule and the oxygen of another molecule. So it's that bond between one hydrogen here and one oxygen here, two molecules, you know, that they are linked to each other. Why does that happen? Because oxygen gives lone pairs to the neighboring hydrogen. All right, see, I can't obviously then becomes a full-fledged lecture, but we covered that in the lecture. So some of the things, if you find you need to learn more, you should revisit those lectures, okay? So anyway, so here is this, I also have short videos, so you can check those also. So anyway, so here is your hydrogen of the neighboring molecule mistreated because the neighboring oxygen is pulling the electron clouds towards itself, causing a positive charge on hydrogen. Clear? The neighboring oxygen is a philanthropist of the periodic table. Oxygen loves to give away those lone pairs. So what does it do? It gives the lone pairs to the hydrogen, the neighboring hydrogen, and forms a very, very weak bond, but nonetheless very strong, that is responsible for the unique characteristic. So now tell me of water also. So what is this here? This, what's the answer here? NH3, excellent. So the answer is C. How many electrons will chlorine lose when it forms an ion? Gain one. Okay. In the process known as osmosis, dash moves through the semi-permeable membrane in the area of dash concentration. So what moves? First of all, see, always the movement is from higher to lower. Higher temperature to lower temperature. Water falls, the snow, or whatever, the rocks fall from height to low, right? On this earth, gravity. So higher to lower things fall. Higher temperature to low temperature. Higher pressure to lower pressure. Higher heat to a lower heat. So same thing here. Higher osmotic, like wherever there is more, water is generally solvent. So wherever there is more water, it is going to move towards that side where there is less water. Okay, so in this case, the solvent is water, not a solute. The solvent moves through the semi-permeable membrane in the area of lower concentration. So that's D, solvent and lower concentration. Solvent is water. So just keep that picture in mind. Water from a higher concentration to lower concentration. Think about it. You can remember osmosis very easily. Think about carrot. You buy food, right? Fruit, the salad or carrots, right? And you put them in the fridge. And sometimes even in the fridge, they become like dried. And then when they become dry, what happens? That means they lost moisture. Sublimation happened in the refrigerator. So moisture got, water got removed. If you put the water, that carrot in the water, it slowly becomes plumped up. So the water has moved from outside to inside the carrot. Lower concentration, where there was low concentration, okay? Okay, last two. The strongest interaction between the molecules of hydrogen chloride. Hydrogen chloride. Ionic bonds, yes or no? No, because it's hydrogen and chlorine, non-metals. Next, covalent bonds occurs, but not, let's see what else. Hydrogen bonds here. Will hydrogen bond occur? No, good. Dipole-dipole interaction. Now here we are talking about, see, covalent bonds is a different thing. Covalent bond is a real bond. But dipole-dipole interactions are like very weak bonds. Attractive forces, basically. So yes, dipole-dipole. Remember, dipole-dipole only occurs between polar bonds, okay? Dispersion forces. Okay, dispersion, London dispersion is in everyone. Dispersion forces occurs where like gases like bromine, chlorine, nitrogen, oxygen. So all those diatomic molecules. So diatomic dispersion, this is dispersion for So this is for diatomic molecules dispersion. But dipole-dipole occurs with the polar molecules. Okay, so one side hydrogen delta positive, chlorine delta negative. Okay, what type of reaction is this kind?
Wait, so which one is study two?
D, dipole-dipole. So there is a difference between covalent bond and dipole-dipole interaction. Covalent bond is a real one where the electrons are like tied up into like into a bonding scenario, sharing, like it's a strong bond. But interactions are like just weak forces, intermolecular forces or attractive forces. Out of those, dipole-dipole is a pretty strong interaction, right? Because one end is positive hydrogen, chlorine is a negative, right? Okay, what type of reaction is this? Last one. Come on. What type of reaction? What is being evolved? What is this? What does this tell you? Heat. So here, instead of writing heat, what is the meaning of this? 218 kcal. What is the meaning of that? Amount of heat that is being released plus this thing. So heat is a part. So this is a exothermic reaction. But if the heat was this side, it would still be positive, like plus 218 kcal plus CH4 plus. So then it becomes endo. Okay. All right, what is a single displacement reaction? Since we are doing this here, what is a single displacement reaction? For single displacement, what do you do? Activity series. Guys, don't forget that.
A plus B, C equals
Yeah,
A, C plus B.
yeah. So this is a part of your activity series, okay? All right, here, okay, 1 second. Hold on, I know you guys are tired now. I know, late night. Okay, here, just don't forget that. Here. There is a lot more, by the way. This is just a beginning, actually. There can be more questions, okay? But the activity series. So you guys should know this activity series here. That the elements that are on the top, they displace the elements that are in the bottom from their bonded state. So that is the single displacement reaction. Now here, if you put hydrogen here, that means the elements that are at the bottom, copper, mercury, silver, platinum, gold, they will not react with the acids. All the upper elements react with the acids and release hydrogen. Okay, got it? So those things. And the rest is, you know, this one and then this. All right, now I'm going to stop sharing and okay. All right, so I'm going to just stop recording. There it is.